Alright, so today we're going over derivatives and rate of change. So there are some few things to note before we start with the questions. So this is the slope formula for a line, or also you could also find the secant line with this formula. And this formula down here is almost the exact same thing except with the limit. This is the tangent formula. So if you want to find, I guess, the derivative of a point, you can use that. And this down here, this is the derivative limit function. So if you want to find the derivative of something, you can use this. And let's visualize this real quick. So let's say this is a position equation. So if you find the derivative of this, then you'll get the velocity. You'll get the speed, position, speed. And then if you derive it a third time, you'll get the acceleration. So that's knowing that the second derivative is acceleration first as velocity is really important, especially for calculus. So let's start on with the questions. Alright, so let's try our first question. So this question is asking us to find the slope of the tangent line to the parabola y equals x squared plus 3x at the point -1, -2. So what we can do is just find the derivative of this d over dx in terms of x. So if we do that, we just get 2x plus 3 because the 2 carries over, the x goes away. So 2x plus 3 is our tangent line equation, but we're looking for the slope. So now what we do is plug in -1. So if we plug in -1, we get -2 plus 3, and that just gives us 1. So 1 is the slope of the tangent line of this equation at point x point of -1. So let's move on to B. Find an equation of the tangent line, which we kind of already did right here. 2x plus 3. That is the tangent line equation for x squared plus 3, which is just the derivative of it. So if this was a position function, this would be the velocity function. It would give you the velocity. Alright, so let's move on to these questions over here. So number 5 is y equals 2 squared, 2x squared minus 5x plus 1 at point 3, 4. So what we should do here is just find the derivative, which would be 4x minus 5. So that's the tangent line equation. Now we just plug in 3. So that would give us 12 minus 5, which would be 7. 7 would be the slope of the tangent line of this equation at 3, 4. Number 6 is x squared minus 2x cubed. So that would be 2x if we derive it, and 6x squared in the after. So if we plug in 1, we would get 2 minus 6, which would be -4, which would be our slope. And now number 7 is a fraction, y plus 2 over x minus 3, or x plus 2 minus x over x minus 3. So now we would have to find the derivative of this. So number 7, we're going to be using the quotient rule here. I don't know if you guys have learned it, but it's basically f prime times g minus f g prime, and then over g squared. So f would be this equation on the top, and then g is this equation on the bottom. So if we do that, so derivative of the equation on the top is just 1, and then g is x minus 3 minus, and then derivative of g is also 1 times f, which is x plus 2, and then over was x minus 3 squared. So if we simplify this real quick, we get -1 on the top, and then we get x squared minus 6x plus 9, which actually on the top it should be 5 because negative 3 minus 2, which is negative 5. And then on the bottom, if we plug in 2, that would be 4 minus 12 plus 9, which that's 13, and then negative 12, so that would be 1. So our slope is negative 5 for that equation, negative 5 over 1. So that's our slope, and then number 8 is it's radical 1 minus 3 at the point negative 1 comma 2. So here we would just we could just use the power rule. So if we put in parentheses 1 minus 3x, it's the 1/2 power. Then we would actually so this equation, this is the chain rule. So if we set it up like this, then we would use the chain rule, in which we take the derivative of the outside, multiply by derivative in the inside, and we just move like that. So if we take the derivative of the outside, we get 1 minus 3x negative 1/2 times 1 over half, because you also multiply 1/2 on the front. And then that would all be multiplied by negative 3. And we're going to have to take some of the space here. So if we rewrite it in like something that looks nice, it would be 1 over 2 radical 1 minus 3x. And on the top, we would have negative 3 as well. So now what we need to do is just plug in 1, negative 1. Since this is the velocity or the first derivative equation, in order to find the slope, we just plug in the x coordinate. So negative 1, if we plug it in, we get, on the top we'll get negative 3, and then on the bottom we'll get negative 1, that would be 3, 1 minus 1 plus 3 would be 4, square root of 4 is 2, and then 2 times 2 is 4. So negative 3 over 4 would be our slope for number 8. And now number 9 is find the slope of the tangent to the curve y equals 3 plus 4x squared minus 2x cubed at the point where x equals a. So all we need to do is just the derivative here. So that would be 8x. We move the 2 in the front, multiply by the 4, minus 6x squared. And since we have x equals a, all we need to do is just substitute it. So that would just be 8a minus 6a squared. So that would be our slope of the tangent line. Now find the equations of the tangent lines at the points 1, 5, and 2/3, 2, 3. So since this is the tangent equation, we could just plug in the x values and then figure out the y values. So if we plug in 1 into the this equation, we would get 8 minus 6. So that would be 2. So 2 would be our slope for the first tangent line equation. And then for 2, 3, we would just plug in 2 here, which would be 16 minus 12, or rather 24. So that would be 8. So 8 would be the slope of the second line. And now, so the first tangent line's right out here, 2x, and then 8x. Let's separate it here. Now we need to find the y values. So we know the slope of this is 2x, and it reaches, it goes through the point 1, 5. So if we go to the left by 1, we just go down a y value of 2. So that would be 2x plus 3. And then since this is 2, 3, and then the slope of this is 8, if we go back 2x units, we go down 16 units. So that would be 8x minus 13. And those are your equations for B. Oh, okay, never mind. I made a mistake right here. So this is actually -8, so that means the slope is -8. So that means the y value now, if the slope is -8x, that means it's going down. So if we go left 2 x values, it should add 16 to the x value. So that should be -8 plus 19. So that would be your final answer for that. And this is still correct. So let's try number 14. The displacement in feet of a particle moving in a straight line is given by s equals half t squared minus 6t plus 23, where t is measured in seconds. So now we have to find the average velocity, in which the average velocity is referring to a secant line, which is a line between 2 points, which it could be shown in the function of I think it's fx minus fa over x minus a. So in order to do that, we just need to plug in these values and figure that out. Alright, so what I've done is I've gone ahead and I've figured out the y values for all the x values that we're using, just so we don't have to stay here and calculate all that. So for the first one, we need to find the secant line from x equals 4 to 8. So what we should do is take the y values and subtract them. We do 7 minus 7, and on the bottom would be 8 minus 4. That would give us 0 over 7. So for this, the average velocity over the interval of 4 to 8 is just 0. 0 probably feet per second. Yeah, feet per second, that would be our units. And then from the interval 6 to 8, we would do 5 minus, or rather, yeah, 7 minus 5, and then we would do 8 minus 6. Yeah, and that would give us 2 over 2, so which would be 1. And that would be our average velocity, 1 for feet per second. So let me circle these. And so now we need to find over the interval of 8 to 10. So 10, the y value is 10 is 13 minus 7 over 10 over 8, or 10 minus 8. And that would give us 13 minus 7 is 6 over 2. So the average velocity here is 3 feet per second. And then 4 is asking us the interval 8 to 12. So we would do 23 minus 7 over 12 minus 8. And 23 minus 7 is 16, and then 12 minus 8 is 4. So this would be 4 feet per second. And now if we look at B, find the instantaneous velocity when t equals 8. So the instantaneous velocity is basically the derivative of the position function right here. So we could just find the derivative of that. So let's write it out real quick. So 1/2 t squared minus 6t plus 23. So derivative of the first thing is we carry over the 2 times 1/2 is 1. So it's just t, and then minus 6, and 23 gets canceled out. So t minus 6 is our instantaneous velocity equation. So if we plug in t equals 8, we get 2. So we could see the instantaneous velocity at t equals 8 is 2. And that could be also justified by here. See, look, we figured out the average velocity from 6 to 8 and 8 to 10, which is like the 2 closest intervals to 8. If we add together, was it 3 and 1? 3 plus 1 and divide it by 2, that also gives us 2 feet per second. So that also like checks out. That's a good way to check your answer. Alright, so I want you guys to try number 17. So you could take a few seconds to try it out and pause the video. Alright, so number 17 is telling us to order these primes and a zero in order of increasing order of slopes, basically, because there's a prime. That means a derivative, which is also the slope of gx, which would be our position function in this case. So first let's place 0 in the beginning, because we know the slope of 0 is 0. Now g prime negative 2, so the slope at negative 2 we could see is increasing. Let's just ballpark estimate it's 2. So the slope of this is 2, and let's find the slope at 0, which is a negative number, as we can see is decreasing. Let's say that's negative 1. And then let's go to g2. The slope at g2 would be, we could also say that's 1, because it's increasing, but it's not increasing like as much as over here at negative 2. And now at g prime 4, so g prime 4 is right here. We can see it is also still increasing, but not like that much. It's kind of leveling out. So we could say that this is 0.5. So now if we increase it in increasing order, we would do negative 1, comma 0, comma 0.5, comma 1, and 2, which would also be g prime 0. That has the lowest slope, and then 0, and g prime 4, and then next is g prime 0, and then finally it's g prime negative 2. Alright, so I want you guys to try number 11, so you could pause the video and try that. Alright, so number 11 is a cliff diver plunges from a height of 100 feet above a water surface. The distance the diver falls in t seconds is given by the function dt equals 16 t squared feet. So this function, to us, it's the position function, or to the equation rather. And the derivative of this would be the velocity function, which we will use in B. So A is asking us after how many seconds will the diver hit the water. So we want to find out after how many seconds, because this equation gives us how many feet it falls when the diver's on a free fall. So we want to find out how many seconds it takes the diver to fall 100 feet. So we would just equal that to 100 feet. And first we would divide by 16 on both sides, which would give us 6.25 equals t squared. Now you can use your calculator for this, but if we square root both of these, 6.25 square root of that is 2.5. So 2.5 is equal to t. So basically it takes the diver 2.5 seconds to reach the water when it's 100 feet above. And now the second question is asking us, with what velocity does the diver hit the water? So we know that this is the position function. So in order to find the velocity, we would have to find the derivative of it. So if we find the derivative of 16t squared, we would take the t over and multiply it. That'll be 32t. Now, we know the diver hits the water in 2.5 seconds. So all we need to do is just plug it into there. And if we do 32 times 2.5, we should get 80 feet per second. So 80 feet per second is the velocity in which the diver hits the water. So yeah, that is for it for number 11. Alright, so I want you guys to try number 15, and so you could pause the video and try that. Alright, so number 15 is we're going to base our answers over this graph on the bottom. So a particle starts by moving to the right along a horizontal line. The graph of its position function is shown in the figure. When is the particle moving to the right, moving to the left, or standing still? So since this is the position function, if the position function is increasing, that means the the person is moving to the right. And then if at a plateau, that means the person isn't moving at all. If it's decreasing, the person is moving to the left because their velocity is negative. So we can say moving to the right, we can say x, it moves to the right from the x value of 0 to 1, and what else? At 4 to 6 as well because it's increasing. And then standing still, it is standing still at 2 points from 1 to 2 and 3 to 4. So we can say 1 to 2 and then 3 to 4. And then left, we see left is the point at which it's decreasing, which is just one interval, which is left is the interval from 2 to 3. So for B, we need to draw a graph here of the velocity function. So what we could do is start plotting points of the velocity at the given times. So we know at 0 the velocity is 3 from the interval 0 to 1, and then from the interval 1 to 2 the velocity is 0. From the interval 2 to 3 it's decreasing, it looks like it's -2. So let's just say -2 is down there. And then from 3 to 4, the object is also standing still, so it's 0. And we want to connect these points. It's showing that the velocity over that interval. And then from 4 to 6, the velocity is just 1, or as it seems. So that's the answer to B, and that's 15. So I hope you guys understood, finding out limits and then secant lines and the average velocities, as well as how to derive the velocity from a position equation. So that's basically it.